This is my work on From Noise to Picture. First, let us see an enlargement of silver particles on the photo film. If you magnify the surface of the black and white film that was once used in photography with a microscope, you can see the appearance of randomly scattered silver particles like this. The random scattering of silver particles takes in light from the outside and change color to form a black and white image. Next is a random dot made by taking a random number sequence from the computer and painting it in black and white. It is random noise very similar to the silver particles from before. The next image is by a person named Bela Jules, who was at the MIT laboratory in the United States, who announced in his research that although it is random dot noise, which is said to be the ultimate in noise, it is possible to hide graphical information in it. It was research on how an image can be brought out of noise by overlapping one part and shifting it. Around the end of the 60s, this research was published in the Scientific American. I was really astonished when I saw it. There is L and R below the random dots. They are short for left and right. The two images were created as stereo images. The two square noise figures on the left and right are projected separately to the left and right eye of the viewer. When the two figures are superimposed on the brain, a small triangle emerges on the screen from the two random dot figures on the top, and a swirling shape emerges from the random dots lined up below. Bela Jules, of course, manipulated random dots using a computer. In this way, random dots that are expressionless and convey no information to our eyes are combined and manipulated to change their appearance into something meaningful. I thought it was an amazing study. Bela Jules also tried simpler examples of random noise that have mirror symmetry that are associated with creatures, as I showed you earlier. Or the example of taking out a part of random dots and arranging them regularly by parallel movement. A rhythmic pattern like a textile pattern emerges. He has cited many basic trials using random dots. Taking a hint from experiments of Bela Jules in my own way, I was able to establish the connection between image and noise. For example, it is inscribed as 50% in the bottom. The black square in the bottom is half the area of the white square on top. It has 50% of the area. The four squares appearing on top, the square in the bottom right, all of them have a ratio of black to white as 50-50. I think you will understand with a glance. The 50% one in the bottom left has one segment. Top left is two segmenting. Going towards right, it is 4 segmenting, 8 segmenting, 16 segmenting, and 32 segmenting. Even though the segmenting gets more minute, all of them have a 50% concentration. As per the regular lattice pattern, it is 50% gray. The next 4 appear below. While the 4 on top are 50% regularly segmented, the bottom ones are randomly distributed 50% concentration patterns. While each of them has a 50% concentration, this kind of a form difference can be noticed between regular dots and random dots. When these two lines of patterns are viewed from afar, all of them should be visible with the same color strength and with 50% concentration. Now let us check up the regular pattern and move the black squares around freely to make a certain shape. The same 50-50% distribution of black and white will draw an image. It is the face of a person. It is shown in the bottom right. The 4 in the bottom of this screen shows a gradual transition of the regular pattern to an image. In other words, it shows the pattern of materialization of a human face. The 50% random dot distribution and the 50% image of a person's face in the bottom are the same in terms of concentration. If we look at it this way, it sways from the regular 50% concentration to the noise on the left side, sways towards the image on the right side. It means that these two operations are possible. In this image, the topmost one is 50% random dots. The center row is 50% human face, and the bottommost is character or symbol. To these three different types of images, I have turned them right, laterally inverted them, and then I have done a negative inversion. If you look at the changes of the bottommost character R, I think you will understand what sort of operations have been performed. The same operations have been performed on the uppermost random dot and the human face in the center. Even so, we will not understand the operations done on the random dot noise, which direction it is rotated, whether negative is substituted with positive. However, we can see the operations done to the human face in the center, rotation, flipped upside down, or negative inversion. When it comes to the character in the bottom, the operations become clear and become easily visible to our eyes. In this way, while having the same density and amount of information, it is impossible to distinguish what has been processed in various ways to make noise, and if you use a solid, well-defined form of a figure, you can perform clearly distinguishable operations such as rotation, inversion, and converting it to a negative. In other words, it can be understood that a picture has the special quality of being hard to break down. Random, regularity, image. That is, we can say that it transforms its shape from being random to an image before changing into something highly distinguishable and hard to break. The next thing that you see is playing with noise, which I thought about as a joint research theme when I entered the Kobe Design University. This is a variety of noise play. First, I have taken an arbitrary random dot noise pattern. Then I will take out a part of it. If you see the top right, there is A, B, C, D written. I have taken and enlarged part B of this noise pattern, which has been split into 16 segments. Taking this B noise pattern as our basis, let us try various operations on it. First, pattern B is cut horizontally into 4 cells, and the top left is the first row, the bottom left is the second row, the top right is the third row, and the bottom right in the bottommost fourth row. Please take a look while comparing to the small image on the top right. Next, Each one is simply repeated 4 times vertically. Then the dot pattern that was sure to have been randomly lined up will splendidly appear as one repeating pattern. Next, we take each quarter of the pattern and shift it repeatedly. This also gives us a splendid lattice design. The small image in the bottom right explains the process. Next, we will rotate it and see. Rotating each quarter clockwise by 90 degrees, a symmetrical figure like this, a symmetrical figure with the center appears. It is a figure exactly of the solid of revolution. If you look at the base of all this, it is a quarter portion of a random pattern. By using simple manipulations on it, it gradually changes towards an image. Next, let us cut out a triangle tilted 45 degrees, a 1/4 triangle, and try changing it with mirror symmetry. By doing that, we get a shape similar to that of a living creature. Next, we take our 1/8 portion and use mirror symmetry on it. It results in a crystal-like image which has perfect mirror symmetry. In this way, I use different operations to make images. Exemplary images are taken and arranged here. The various shapes that are lined up here are all results of operations such as lateral displacement, repetition, rotation, and mirror symmetry of the section of the noise pattern B placed in the upper left-hand corner. It can be said that they are children of the noise pattern B. Next, I collected 4 of each and combined them as an aggregate. Now the figure is complete and the noise pattern on the upper left is the prototype. But it is an unimaginable collection of vivid figures of children. An interesting pattern like a carpet is woven. Then we will add another operation. This carpet noise pattern collection is cut and is laterally inverted. Doing that will give us this. Furthermore, if we laterally invert this, we get this form, inverting it again and again. This will change into a complex, what do I call, an image that can be thought of as a painting. The entire image is based on the small noise pattern called B that we saw earlier. It is just one. Taking a cue from this development, I use mirror symmetry and combinations to continue to create noise patterns. After that, this noise pattern move on to be file stamped cover of Leibniz collected works. And in my office, there is another box called All Sorts of Noise, where you find a collection of noise manipulations. This is the noise pattern I use for the cover of Gen Uchushi Sama Cosmographica. In this way, from 1964 to 1966, I developed the exploration from noise to figure or the manipulation of noise patterns from an information aesthetics perspective, which was inspired by Bella Julle's trials.